Okay, we'll start now today's session. It is about industry interaction. So today we have with us Mr. Amiya Kumar Samantray. He is an alumnus of VLSI department, our department, Department of Electronics and Communication Engineering. He is a fellow member of Royal Academy of Engineering UK. He is an engineer, innovator, and entrepreneur, having built brands such as Oral and Adams. Amiya has employed over 100 engineers in the last 5 years in the field of IoT. And this is a less introduction about more about himself. He can tell, and he will help us to learn about his company, which is gateway for IoT, AI based, and cloud and data science. Many things he used to tell me when we interact over phone. Okay, Amiya, we can start. Please start. Okay, already your slide is there. We can start. Thank you for joining.
Thank you, sir. Thank you, sir. Thank you so much. And good afternoon, everyone. So this is Amiya, founder of Day1. So it's actually honor to back in the campus or like virtually and presenting to all of you. And it's a nice experience for me. After long years, I'm presenting to NIT Forum. So primarily what I'll try to do is like I'll try to talk about what Day1 is building in terms of industrial solutions in the distributed asset sector, and I'll just touch upon a few of the security aspects, which is the like theme for this workshop or the program you have been part of. So I'll start with the like what exactly we do, how we are using technology, how we are leveraging IoT in our hardware and software domain to solve the large problems across the globe. So Day1 is a deep tech company focusing on simplifying distributed operation. So when I talk about distributed operation, I'm primarily referring to sectors such as construction, logistic, warehousing, mining, oil and gas, where you see operation happening in distributed or fragmented geographies. So you have pockets of machines in one place, and then you have some other pockets of machine in some other place, and it's fairly distributed over multiple kilometers or maybe multiple geographies or multiple states or multiple countries. So that's the area where Day1 believes that IoT, the need of IoT is more compared to a factory floor where there is a SCADA or a PLC is already in existence, where you have all the data available. So that with that belief, we started Day1 and we are trying to solve this problem. So what the core problem that we are trying to solve in Day1 is standardizing the legacy operation to a digital connected ecosystem. So if you talk about how operation being carried out in these sectors, taken a typical example for oil and gas sector. So you have ONGC as one of the largest oil producer in the country. So who have gas wells or oil wells at different places. And all these oil wells and gas wells are in different pockets or different places. So you have like a pump or a generator or a compressor. For like all this gas extraction, you have different kind of equipments which is lying on a particular site. And so the way the maintenance has been carried out in the past is like say they have phone calls or somebody needs to go to the site to maintain the logbook or spreadsheets, and they will have physical inspection. And the person who is doing the physical inspection is not technically sound enough to debug or diagnose the issue about the machine, or they can't optimize the production process. So that's where the question of connected operation comes into existence. So we are talking about operation where all these machines are connected to a centralized cloud platform or a centralized dashboard, where somebody can monitor all the utilization parameter, get an operational view or operational dashboard, so that you can see the utilization of the machine, how the machine is being run, what are the criteria, what are the parameters that is maintained for different type of operation matrices or operation targets. Then you have alerts or alarms for the machines, which if it is deviating the standard operating condition. Then you have predictive maintenance on top of it. Like once you have all the data of all the machine and the digital twin is being created, then you can create predictive maintenance tools for the asset owners or the asset manager who is managing in a centralized location. So Day1 is trying to build a digitally connected ecosystem fundamentally shifting the operation that are being carried out in the past through the human intervention. So we're trying to help like empower the people so that they can address or they can accommodate more and more sites with limited number of manpower. Because COVID has also already is a push like of this kind of thought process where people are not allowed to travel. It has to be local driven, and the knowledge base has to be central, because usually, so if you have if you have manpower who don't know about anything about the machine, so they can't actually help it locally. So you need centralized access, you need centralized data. So those are the drivers of our industry. COVID has been an accelerator for adoption in across many of the industries. So this is what broadly our tech is. And if I talk about the platform, so primarily we are a hardware-enabled software company. So if I talk about our gin, so I'll be more like a software company rather than a hardware one. But we have like say hardware stack. That means like we have gateways or sensor devices which connects to the field assets. So in our platform, we have these key features, or like say, these are the fundamental features across any IoT platform. If you look at Datum's IoT platform is built from scratch. It's very similar to what ThingsBoard is, or like say, you might have use ThingsBoard or UBDots or some of the like open source platforms. But Datums is primarily for the asset equipment owners or the equipment manufacturers or leasing companies or large enterprises. So we primarily focus on B2B as our customers in this segment. We work with some of the leading companies like say Mahindra. So Mahindra is using our platform for some of their equipments, which is being dispatched to the market. We're working with Caterpillar, we're working with Ashok Leyland and some of the leading OEMs of large scale equipment. We are also working with some of the leasing companies, asset leasing companies, to where the connected asset leasing is done on our platform. So one is we're talking about the IoT aspect, where we're talking about equipment monitoring. That means we're talking about the digital twin and getting data from all varieties of sensors, all variety of machines. Then you have real-time triggers and alarms, which is typically is a rule engine. So as you call in generic term. Then you have reports, so reports management or asset management report or utilization report. Then you have device management, which is configuration, authentication, or provisioning of the IoT devices, how you manage the device, how you manage the error log or history, data history, or data crunching of all the IoT devices. Then on top of it, then we have different data-driven business models. So data-driven business model means once you have a connected asset, then you can enable leasing as a function. So imagine a future where you don't have to buy a machine, rather you are leasing a machine for your day-to-day operation. Imagine your water purifier on rent. Imagine your AC on rent. So suppose you're traveling to a new city and you don't have to buy everything just for a few days. Rather, you lease out machine and you pay as per your use. So those are the kind of business model what we believe that like say we are heading towards in the future. In the next 5 to 10 years time frame, these will be very common across geographies, and IoT will enable those business models for many of the startups or many of the industries. So Datums wants to be a platform enabling these services. So equipment as rental, spare management, service workflow management, warranty management. In warranty management, you can think about like say personalized uses. So if you are a user who is using your machine in a better way, so you should get rewarded rather than a user who is not using the machine in a proper way. So if you are a good user, so you'll be rewarded with extended warranty for 6 months. If you're driving a car better way, so your insurance premium would be different, and or your loan interest would be different. So those are the kind of business models that's going to come in the future with the connected asset, which Datums is enabling. So this is a like a generic architecture, I would say. What like applications we are hosting. We have like say different industries, different machines. We have different like libraries which goes inside the hardware for different varieties of machine. So we kind of, so that's kind of our proprietary libraries we create for different asset categories. So our platform is asset agnostic, or like a machine agnostic, I would say, where we have different varieties of machine that can be connected to our platform with few clicks. So the customer doesn't have to understand how IoT works and how things are working in the backend, but like say he can just plug in the device and everything is set. So there he sees a dashboard on the platform. So we are trying to simplify the onboarding process through our tech, through our platform, with the libraries, the bouquet of libraries we are building for different varieties of machines. Then you have the data, IoT data layer, where we do the backend processing, crunching, and the basic filtering of all the data, that's stream data, real-time data, which is like handling. So right now we are handling almost 250 million data points every day. So that's the kind of data volume right now we are dealing with. And on top of that, you have aggregation or enrichment of the data. That means like we are talking about using AI or machine learning for forecasting a pattern, or maybe forecasting a failure, or you can use reinforcement model on top of it to create a reward system where, let's say, you can direct reward the activities, and you talk about the health index of a machine. So those are the different aspects of, like say, analytics that we are trying to create. Then you have, like, say, different application, which is for the end customer. It could be a vehicle telematics, it could be a equipment monitoring, it could be site visibility. Site visibility could be telecom, could be construction, could be mining. So these are, like, say, site visibility use cases. Then you have equipment as a service, which I was talking about, leasing as a business case or leasing as a model. Then coming to like the core, where maybe like say I could not maybe touch upon like everything in detail, because security is a very large aspect. Now in security, I would like to touch some of the key aspect which Datums is concerned about, or Datums has addressed it inside on the hardware side, on the hardware stack. So one is like say one of the key challenge we see in the like Internet of Things like architecture is the device credential, like how you provision your devices. So because you have, like, say, like right now, maybe we have around thousands of devices at different places, and you dispatch your device to different place. So you are not restricting physical access of your device by a third party. So anybody can access your device. A plant person can access your device. Somebody can get the QR code or the ID of the device. So how you secure the provisioning of the device? So how you know whether the device is yours or not? So most of the time people fail that, like say, they use fixed kind of a credential. They use a token based credential to like say authenticate or provision the device on the IoT platform. So what we do is, like say, we use fixed as well as a dynamic option, where the credential gets auto refreshed every 1 day. So the credential, the key that is being used in the device is different all the time you connect on a day-to-day basis. So you don't know like what's the credential all the time, and that credential is not known to anybody. So for the first time provisioning, there is a fixed key which is directly goes with the device with the QR code. The QR code can access the data. So it's a OAuth verification process that we follow for the device registration or device provisioning. Then you have this dynamic like refreshing of the token or the key that is being exchanged with the server and the device. That's the first component. So that's the area where there is a concern about getting this credential getting leaked, and you can't be bombarded with the data because once the credential is through, so the device can start pushing the data to your like server. The second component we are talking here is, like, say, how you store this information. Though the like key is refreshed or you are changing the key, so how you're storing it? Like, say, is it encrypted? Is it is your firmware encrypted? Is your data that is being generated, the sensor data that is being generated or stored in the memory are encrypted? So we are using AES 256 standard of encryption for all our firmware, the storage, local storage, security, then the key stores. So entire storage is encrypted. So definitely, so there is an area where you guys can work on like enhancing the security aspect in the storage, how you efficiently or securely store the data. So and also that depends on the ones, because you're talking about low end devices where the footprint is very low. It can come down to some MBs to sometimes like it goes to some GBs. But the question is, like, say, maybe if you talk about lower footprint devices like small sensors, it will have maybe 256 KB of memory or 256 KB of RAM. Sometimes it goes to 4 MBs, 8 MB, 32 MB. So in those scenarios, so definitely you have limited resources in terms of computation. When you implement something, some algorithm, if it is not implementable in the hardware, then there is no point. So till date, AES 256 remains as the core industry standard for security for data storage. So we use AES 256 for store data storage encryption. Then the third part comes as, like, say, is there any physical hardening or like binding, like, say, is there any physical map between the authentication credential as well as the device? So we use IMI number, which is very core to the device physical behavior or physical signature for any kind of telematic devices or a Wi-Fi, maybe MAC ID, or so all these things are used to generate the authentication key or generate the password, so that, like, so it is getting validated with the physical hardware. If you change the physical hardware, then it will be detected in the server that the underneath physical hardware has changed. So that's one aspect that we have tackled. Then the question is, like, then we are talking about data transmission. So one is data in rest. Now we have spoke about data in rest. Now we are talking about data in motion. So whenever we are transmitting the data, so whenever the data is moving from one component to another, so is it? I'm not talking about, maybe you can talk about maybe sensor to gateway communication or a wireless network communication. If you're like deploying a LoRa network or a Bluetooth network or a Wi-Fi mesh, how you manage the local security. That is more about a local security, how all these communications are being done. Except like the data in rest security is a different thing. But like one is how you are managing the data in motion security. So there also we are using AES 256 encryption for all our communication, back and forth communication. So that's also very critical because somebody can tap into the data through like IP like decoder, like where they can see the data, see the packet, see the data volume. So if you're talking about sensor data, might not be very dangerous, but if you're talking about healthcare data, so that there will be a lot of concern like on the getting the data, the data getting hacked or data getting bypassed. So definitely, so that also a crucial part of data security. Then we're coming to how you update the firmware, because like how over there programming happens is you're not just deploying, you're not releasing a firmware for one device or 10 devices. You are just releasing a update for, like, say, maybe thousands of devices, and that update will be happening like, say, on fly. So nobody is looking at how who is updating, when the firmware is getting updated. There is no user who is confirming that, yes, I need to update the firmware in my device. So the device is actually auto downloading the firmware and updating it. If it downloads a wrong firmware or a vulnerable firmware and start like giving it access to the entire network, that could be a like dangerous scenario. So we need to ensure that the firmware update is proper. So we have a, like, say, security based authentication process. So whenever before you send the firmware, we send some security data packets, which is kind of a validation check whether the source is valid or not. So the device ensures that the firmware which is being like, say, deployed in the, like, which is actually the firmware from the source of the firmware from where it is coming. So it's a authentic source. It's not a, like, say, dummy source. It's an authentic source, and then only it downloads the firmware and ensures that nothing is wrong. Then the third part is, the last part is, yes, this is a web security standard, which is very common. So you can maybe go through wiki, and this is more related to the web application and web interface, which I thought like not to address here, which is very common in the web world, OS. OWASP, which is standard. If you want to be a partner with any of the large corporate companies, so your web application or the platform should be complied with this standard, OWASP. So that's the common security standard for like any security application or any IoT application you have to follow. So this is like, say, these are the broader aspect. I just touched upon some of the things. There are many other apart from this. But like primarily we are concerned about these things. We have tackled like these things in our devices, in our format stack or in our platform. So that's what, like, I have updated, and I'll just go like give you a glimpse of the overall architecture of our platform, which is it's a very like larger or maybe superficial view or a very macro view of the entire architecture. So I can't talk about very in depth of all these things. So these are, like, say, the end nodes. Then you have this gate connectors. Connectors could be software, could be a driver, could be a gateway. So then you have a security layer. So this is the layer we are talking about. This is data on motion. So we're talking about AES-250 inscription. But like in the gateway, I spoke about like what are the things we have done. Then you have this acquisition layer where all these protocols are getting converted into standard formats, or then you have like say data streams, like you have different microservices running on different Kubernetes instance, like say, that server part is different. But broadly, if I talk about IoT security, so the entire stack goes in this space where you have these machines and these machine data coming to the connectors, and data getting stored, data getting processed in the edge on the cloud, then getting transmitted to the data acquisition layer. So that's where the web kicks in, and the security stack for webs comes to existence. Yeah, I think so. I'm pretty much done with the presentation. So I'm actually yeah, would love to take some questions, and maybe if you have any questions related to the industry, related to the security part. So I may be able to answer some of them, may not answer some of them because I'm not the one who is developing or working on all the stacks. But I would like to maybe I would try my best to help you. Yeah, thanks everyone. So we can take questions, or people maybe can post it, or maybe they can directly ask.
Yeah, okay, thank you, Amia. I will just make them presenters so that some of them may ask some question.
Sure. So you can maybe share our feedback, like say whatever I have spoken, maybe. So if you understood it, or like maybe if you have any question is fine, or if you have maybe some points are not relevant to you, you can share your feedbacks.
Any question? Any question from here or from online? Okay, I think all are not having all understood everything. So I can put 1-2 question so that they will understand it in a better way. So like one common question is like actually what actually IoT gateway does. Like you are telling that you all are having a good market of IoT gateways. There are a lot of competitors in market also. So what actually we expect from the specification of gateway and how it is actually very helpful in IoT system.
So primarily, if you talk about IoT gateway, so think like a router. So if you have, like say, Wi-Fi nodes or Wi-Fi end sensors, uh, you have, like say, you need to connect to internet. The gateway does is like what the gateway does is like it works as a bridge between the physical machine and the internet for IoT device, right? So in gateway, so it can connect to it. That means like so we are talking about two aspects here. One is there are physical devices or physical sensors. So the physical sensors needs to interact with the gateway either in the form of different protocols. It could be through Wi-Fi, it could be Bluetooth, these are the wireless protocols, or LoRa or Sigfox. So these are the wireless protocols, how it interacts with the gateway. Then there could be wired protocols. So you have RS485, Modbus, BACnet, CAN, Profibus. Like there are many protocols which can be used to communicate to the physical gateway. So these are the So one is like how the field asset is communicating with the gateway. Then how the gateway is transmitting data to internet or to the cloud. So either there are three fundamental mediums. One is LAN, fiber, or Ethernet. Then you have Wi-Fi. That's the Wi-Fi wireless network. Then you have GSM or maybe 4G LTE or now 5G or now maybe sometime later you'll see you're looking at 6G. So those are the ways how you connect to internet. So the gateway could be, there are two types of gateway. One is a generic gateway, so which is like which does nothing, just transmit. Like say it acts like a tunnel. So it just give you a tunnel access of the data. Like all the data that is being bombarded to the gateway is broadcasted directly to the server. So there is no processing happening in the gateway, no like processing, no intelligence getting added in the gateway, and just broadcasted to the cloud server. Then there is a second category of gateways which does edge computing. So there is that gateway captures the data, processes it, converts into different like analytics or different. They derive different value out of the data that is being captured, and then it share the process data and take intelligent decision on sharing the data. Just imagine a use case. So your car, like say, so connected car, you talk about, like say, you think about like a Tesla car, like how they are doing is like, so that is a edge gateway with edge computation capability, because whatever real-time application we are thinking here, so if the machine needs to act on the real-time feedback of the sensor on an immediate basis, so it takes a lot of time for the data to go to internet and comes back for the action. So the action needs to be local. So that's where the existence of edge processing comes into picture. So you have to process the data in local. If you have an application where you need to take action basis on the input, suppose like say controlling a motor. If I am controlling a motor and I can switch on and switch off the motor, and there is some activities which has gone wrong, and I can sense that input, and I can prevent disaster locally. So that has to be done locally. So you have to have edge computation capability in those cases. But if you are only talking about just getting the data, so you can use a gateway which is directly transmitting the data to the server. There is no processing in between. So depending on the these two fundamental objectives of the gateway, like whether you are going to process the data or you are not going to process the data, so the architecture of the gateway will completely differ. And in the gateway, you have like either you have to have a single mode of communication or multi-mode of communication or multi-mode of transmission. That means, do you have a redundancy? Redundancy means like either you can use dual SIM for redundancy, or you can use Ethernet and GSM as a redundancy, or you can use GSM, Ethernet, dual SIM, everything in a single gateway, so that you ensure that 100% data availability is retained. Many of the smart city applications, many of the like say government applications where the gateways are used are having all these four mode of redundancy. That means they have Ethernet, they have Wi-Fi, they have 4G LTE, as well as dual SIM. So you can imagine, like say, so you can, definitely. So all these features comes with a cost, comes with hardware architecture. So if you have to use like say 4G LTE and like Ethernet, Wi-Fi, and want to accommodate a lot of sensors in a single gateway, so you need to have that processing capability as well. So maybe at least you will be needing maybe 256 MB RAM or a flash, so that like and at least you should have a OS in your system.
Yeah, okay. Then what I understood is gateway is a system which we can connect to any physical system which doesn't have any medium of connecting to web. Is it so? We can connect it if there is a pneumatic controller and in an instrumentation industry, and it doesn't have any mode of communication to web, then we can connect the gateway, and depending upon the RS-485 or other communication, so those protocol which supports by the gateway in one side, so we can connect those controller to this sensor actually also, and in other way it will send the data to cloud. Is it so?
Right. Yeah.
So
In case of instrumentation, so
where actually in IoT system you like in your system where you are using this AES, you told it is in gateway side, or you are using in cloud side, or where? Like to add security, maybe encryption based
Yeah,
security.
right. So I spoke about two parts. One is the data in rest. Data in rest means like how you store data. So in the device. So if you are storing data in the device, so all the data that is being getting stored in the device has needs to be encrypted. So that's where, like say, the AES 256 engine comes into existence. So you use AES 256 to encrypt all the data points that is getting stored in the mesh device itself. So that's the first part of AES implementation. Wherever you store the data, whether that's a firmware, that's the data, or you have memories. So you use encryption to store the data. So there are, like say, processors which comes with a built-in option, uh, like who does the encryption on its own in its engine and like stores the data for the firmware stack. Then you have like say data in motion. Data in motion means like when you are transmitting the data from the gateway to the server. So then you have to encrypt the data while you send in the device only. So you have to use AES 256 encryption when you create a packet, when you create a data packet which will be sent to the server. So you need to use AES 256 to encrypt the data and store it there.
Okay, I also understood out of this that you are more into smart manufacturing system, which is I think one aspect of the IoT, like apart from various applications like healthcare or smart city and all, more on less you are into smart manufacturing or industrial IoT type of application. So can you just list
Right.
us some use case where you people are like I have heard somewhere like it will help, IoT will help in building or developing a functional safety security for a like smart manufacturing system. So can you just help us to understand like how this will help to create safety or security for certain use case what you are doing in ONGC or some oil company and all?
So I would suggest, like say, maybe some of the people they can share their research interest areas, what they're doing exactly, and how they see IoT security to help in their research. So, and then I can add value there. Like that will be more interactive because the conversation still remains a one-sided discussion. Like say, I would suggest like maybe if few of them can share their work areas, where they are working, what is their problem statement, and maybe so that's where maybe so I can add something. Is that fine? Like with somebody sharing or two, three people sharing their interest or what is the problem area they are working on, some of the problem statements they're working on, and how they see IoT helping in their research or particularly maybe IoT security helping in their research.
Okay, anyone wants to share their idea or research idea if you are doing in anything in on IoT or not? Sure. Mike there.
Hello. Sir, can you hear me?
Yeah, I can hear you, but I can't see you, I think.
Sir,
City जाओ, थोड़ी चिकराई से देखो, स्टेज थोड़ो.
Yeah, you can ask. Yeah, I can see you now.
my question is like there are different industries who they don't want to share their data. They need the privacy. Now, for those industry, what type of challenges you are facing while designing the gateways? Now, there are different protocols, as you said, LoRa is there, Bluetooth is there. So, what type of what sort of things we should consider there if industry don't want to share their data? And like you also suggested about the healthcare industry. So what is your suggestion for that? What will be the what will be the channel what type of things we should consider while starting our research?
Right. So nice question. Actually, so this is a primary concern across the industry. But while designing a gateway, that's not a concern because that's a cloud versus on-prem decision. So what is like so when you're talking about data security, like say imagine your Sun Pharma. So question is like say whether all of your machine or all your data is on the cloud or on the premise or maybe on the local machine. So one is like say the usual mode of security people follow is like say keep all the data local to the system, so or local to the PC. So when you're designing a gateway, if you're processing all the data, processing everything in the gateway itself, and you are also creating a hotspot, which is or maybe a web access platform in the gateway itself, rather than sending the data to the cloud. So everything remains on-prem, like everything remains like local. So it is not going to the cloud. It is not going to the internet. So that means like you are designing like say distributed system or a system where the data is not coming to the cloud. So that is one way of keeping the data, which is private to you. But when you're talking about implementing machine learning or AI or like the data science, then you need to bring all these data to cloud because AI is not possible on the edge or right now, like say AI has to be, you have to bring all this distributed data into a single platform or a single engine where the AI can learn and then give back the result back to the like end node or end local system. So in those processes, you have to follow the security standards while storing the data, while transmitting the data, and comply with the certification norms. So that's the way. Maybe that's the way you can convince the industry, and that's where actually the research area is. Like say, I highlighted on these two aspects. Like one is data in rest. So either if you're talking about a research point of view, either you can work on like say data on rest, how you secure the data when it is not moving, it is just stored in the device. So how you can encrypt, how you can like block the access, how somebody, if because the device is physically accessible, so anybody can access the devices physically in the field, but they shouldn't be able to understand the data, they should not be able to fetch the data. So how you are securing that, so that is one aspect. Then the second aspect is data in motion, how you secure the data which is moving, which is transmitting, which is getting transmitted. Did I answer your question? Did I like say could address some of your doubts? I can't hear you.
Okay.
Sir, what such protocols are better for industrial IoT? And actually, if we are using LoRa in the place of any other low power protocols, then is it? I mean, I need your suggestion on this.
So for see low power, like say, I think LoRa is very one of the like great standards that has come a long way. Then Sigfox is there, which is widely adopted across Europe. You have but like broadly, I think Bluetooth 5.0 has given a lot of options for like say smart home applications as well as industrial applications. Then Wi-Fi is also coming, like Wi-Fi, the upgraded protocol format is coming. So the Wi-Fi and Bluetooth is actually evolving very fast, and I would think like say maybe those are because most of our devices or most of our interaction happens around Wi-Fi and Bluetooth. So the more and more robust these protocols become, so we'll have more opportunity to tap in more amount of data. Then beyond that, you have NFC, then you have, I think, in one of the wireless communication, Zigbee is there. Then you have JetWave is there. So all this, there are a lot of local protocols are there, but these local protocols are restricted till the gateway. Beyond gateway, there are like you need connection to the internet. So either you have to be in Wi-Fi or Ethernet or 4G LTE or maybe 5G. So connecting to internet is one criteria, and then creating the network in the local environment is a different thing. So the near wave, the near field communication, Bluetooth, Wi-Fi, like say LoRa, Zigbee. So all these protocols are like say local to the gateway. Maybe you can think of like any of those protocols.
Okay, thank you, sir. Thank you.
Thanks.
Hello, sir. Am I audible?
Yes.
I'm Sandeep.
Who is?
Sir,
Hey,
can
hi,
you hear
sir.
me? Yeah.
Yeah, I can hear you.
Yeah. So actually, sir, I am working on some of the topic wherein this nodes are assumed to not be very computationally competent. I mean, there is like
Okay.
there is no luxury of this 256-bit AES and so on and so forth. So,
Okay.
sir, I was just wondering, I mean, can you just throw some light on some of the applications or use cases when it is practically, deployed, and what are the issues basically with such kind of nodes?
Yeah, I think one is like say if you talk about the gateway point of view, so all these low nodes, like you talk about so suppose like say ESP32, one of the popular processor that is used in the IoT community, has a support of AES-256. So it has a built-in encryption engine, which is AES-256 comes as a built-in option. If you use Expressive IDF, you have to go out of the box of Arduino platform. So you have to come to the RTOS platform where Expressive has its own like say development environment, and all the APIs and libraries are already there. So the AES-56 is available at this low footprint hardware. If you choose any of the like say 4G LTE module, like be it QuickTel, SimCom, you have then you have Syra, you have like say then Texas Instrument. So all these 4G LTE modules have core like WRTOS, so which is a open source Linux, modified Linux, embedded Linux OS. So which is common across all the gateways. Like say you'll find 95% of the world IoT gateways are run on these OS, WRTOS. So you can, so one is like say one is when you talk about a gateway, the security is a must, but the end node you can compromise on the end node. So the end node can have it can be used without any security, without any encryption. So I would recommend you to, like say if you're using an 8-bit processor or a 16-bit processor, a small processor having 8 KB memory or 16 KB memory or 256 KB memory, so it's better to put those nodes as end nodes or maybe a sensor nodes. Okay, and don't put it as a gateway. So when you are using a gateway, at least you come to a point where the gateway has a support of encryption, because gradually, if you talk about if you are provisioning it for AWS or maybe Microsoft Azure or UBDots or any of the IoT platforms which is popular in the world, so everybody has a support for security. And if you want to develop a commercial level application down the line and want to commercialize your research, so that would be my recommendation. Use the low footprint devices for the end node, not for the gateway.
Okay, fine. So low footprint devices for the end node, fine, sir. So, but then what are the options when it comes to providing like let's say security to those kind of end nodes? What could be the probable? Yeah.
So maybe you can use maybe RSA you can use for the authentication, local authentication. Then you can use maybe AES-128. So, but the question is like you need to write those libraries. You have to write those libraries. If you are not finding it, maybe the library would not be fetching you a lot of memory. So AES-250, AES-128 is I think pretty low end, which like say it's not very computational heavy. Then you can use maybe DES. So those are the other libraries which you can try out. So if you look at like say some of the popular microcontrollers like Arduino, or like say you can Arduino Uno or Arduino Mega, so like Atmega 328 or maybe Atmega 2560, all these processors can support I think AES 256 or 128. So I don't know, like say, I think what I can imagine is like say that's the lowest bit, like computationally low hardware or computationally minimal hardwares, those are available. So if you are going below that, maybe tiny, maybe like 4 kbs, that I have to check. I'm not very sure, but AES 256, AES 128 should do.
Okay, sir. Thank you.
Thanks.
Okay, there is another question from here. Joy or PhD scholar, he will ask. I have a just suggestion. Amir, can you just share some of your device which you are marketing, so that they will have more interest? Like means we are talking, but you have shown the architecture. But is it possible to show here just device photos and all, some sort of that? Is it allowed or
I need
possible?
to check. Let me check in between. Like we can continue the question, and in between I'll just check if I can share the photos.
Okay. Thank you.
Okay, sir. I have a small question, but it is slightly out of topic. So my working area is on low power devices, as in development of devices for this ultra low power nodes. So we know that for IoT we have power constraint, right? So do we have any benchmark or any such data available, as in what kind of power supply, energy consumption, or battery specifications would be required, so that when we kind of design these devices, like advanced devices like tunnel FETs, and also we can keep in mind about what should be the supply voltage and these things. So is there any kind of benchmarking data available which is specific to any particular industry, so that we can refer to that?
So one is like when you're talking about IoT devices, the power supply could be two ways. One is a devices which is purely battery powered. Okay, so purely battery powered devices, like it maybe powering with a lithium ion cell or maybe a coin cell. So coin cell based battery or coin cell based systems. So those are like purely battery powered. You will find lot of temperature nodes which is coming with a 3.3 volt coin cell battery, and it can last up to 5 years or 10 years, which can transmit data using Bluetooth or a Wi-Fi medium. So those are that's one system. Then you have like say system where you have AC supply or a DC supply. That means AC supply is not required. Like they basically a DC supply which is 12 volt, which may vary from 5 volt to 30 volt. So that's the range, DC range, that primarily most of the IoT gateways are working with. So if you talk about like purely battery power devices, most of the battery power devices are 3.3 volt driven systems. So most of the circuit, most of the internal components. So if they require 5 volt, they will use a boost circuit to boost it to 5 volts or like to use it. But primarily, if you low power devices, it's restricted to the input voltage is 3.3 volt or 3.7 volt as per the lithium ion battery standards. So that's the benchmark for the battery power devices systems. Then you have this AC system where the voltage can vary from 5 volt to 30 volt. Sometimes it can, see, if you're like right now, like EVs have come up with like say EV system that can goes up to 98 volt or like say sometimes. So that's the range. So that's a very big range when you go to EV as a asset category, EV as a machine. But if you talk about the largely industrial devices, the DC voltage supply range could be 5 volt to 30 volt.
Sir, this 3.3 volt that you're talking about, the battery driven devices, that includes all the peripheral circuits. But what about just the IoT node or just the main computation element? How much power does that require?
So most of the cases,
excluding the peripheral circuits and other components which might be required for any particular application. I'm just talking about a raw IoT node or a raw computational node.
So for your reference, I can tell you, like you can check for Teletonica hardware. So Teletonica is one of the pioneer in IoT gateways and sensors. So I'll just show you few devices. Like so, they have a lot of battery power devices which works for 10 years. We have been using their devices since long time. So they have temperature node which is working 10 year with a 3.3 volt normal cell battery. So the current consumption is in milliamps, and the deep sleep current is in microamps. One microamp, two microamps is the total consumption in deep sleep mode. So 10 to 5 milliamps would be the general consumption when do the data transmission. So I am just putting that link in the like chat box, so all of you can refer to that.
And sir, are these data universally accepted, or is it specific to this particular company which you're talking about?
So this is universal. Like if you go for like say any battery powered devices, it's the 3.3 volt is the system. So this is a very good example that I have given. So you can refer to those devices if you want to like say maybe tear down some of the devices just to get to know what are the ICs or what are the architecture they're using. Break few devices, understand the architecture, you'll get to know like how they have done it. So the devices are not costing much. 1,000 rupees, 2,000 rupees is the one node. So you can purchase few, you just break it and get the idea.
Okay, thank you, sir.
Okay, thank you, Amir. But I also suggest, can you just, or we can go to your website and see it, your devices.
Yeah, I'll just open my website. I'll show that. I think, but I don't know, like say whether that makes many like that will really help or not. But like let me say that.
I am telling actually when we saw devices made and I saw your growth journey and growth from last 3-4 years. So you started with a pollution monitoring system which you supplied here to Siba Cement near Khanswal, and you are going there and just doing many things, and you sharing your ideas at that time as a single fellow in a company or two fellows in a company. And from there today to this place where you are selling gateways in parallel to other companies in the market. So that's why if we saw this type of device, so sometimes our vision improved and we'll try to make such device. So no doubt computer science guys will do software for it and electronics electrical may do hardware for it. But if you will see it, then we can inspire to do certain thing from industry point of view. So like you did, so we'll try to do. Sometimes we can take help also, like you people, and we can go ahead with coming up with our own solutions. Maybe academics, not for industry, or in a long run, it may go also for the industry. So that's what I suggest. If you can show anything, so it will be helpful. So after that, we'll end this session.
Is my screen visible right now?
Now nothing is visible.
I'll just. Let me. Is it visible now? Can you see my screen?
Yes, yes.
So one is like these are different gateways that we have. Like say you can see we have a like a universal gateway which is which is having different modes of connectivity. So this is the gateway built like say like maybe initially like we have built it in house. So by ourselves and like design everything is ours, like entire IP is for this device is ours. So nothing is outsourced. Only we are out like we are doing the manufacturing is outsourced to third party, so which is who is doing the manufacturing. So this is so this gateway has different input interfaces. It has RS485 Modbus, RTU, TCP both. So you can see the Ethernet ports here. So one is there are two Ethernet provisions are there. One is for the RS4 like for the Modbus TCP you need Ethernet. Then you have USB pins. You have actually these are the like this is a rubber placed area where the SIM cards and SD card and USB is there. We have a provision for let's say multiple connectivity option. We have 4G LTE, Wi-Fi, Ethernet, Bluetooth, and LoRa in the single gateway. So then you have like say this is the security standards that are being followed in the device. Like I have already spoken about it. Then OTP or secure boot, like over there programming is supported. Then the devices like this is a we are providing a DC as well as AC option, so you can directly connect normal power, like say AC to this device, so 230-volt AC directly you can supply to the device. It has a built-in adapter, or you can say built-in switch mode power supply, which converts 230 to the required DC voltage. And also it has a solar provision, solar port. You can directly connect solar panels to it. The device has a built-in battery, which can work for, like, it works like a backup. It's not a low power device, it's a backup battery. Sometimes if the power is down, the device will not go down. Rather, it will transmit data for like say 12 hours or like 8 hours. The battery device is there, and there are a lot of protection. So like you have surge protection, ESD or EMC, or over voltage over current protection. So all this are there in this device. So this is I think this is one of the uh, like good gateways that we have designed in house, and one of the key hardware that we use to connect multiple hardwares. Then we have a low-end hardware. Low-end hardware means like say low-end gateway, which is a single mode of communication, single mode of transmission. So this is called as like a trade GPRS. Trade means actually we call it like say TRADE. So you can say TRA is the transmission, DE is the device. So TRADE. So it's not trade, but like we call it TRADE. So TRADE GPRS. So you have this here, you have limited inputs, and one connectivity option. GPRS is the primary option. We have both versions available, 4G LTE as well as 2G, 3G here. And we support dual SIM in this device. Then you have, like all the other standards are common. So yeah, so this is broadly the devices we have. Then we have another device for. So this is also this is for industrial, but like a similar kind of interfaces, but the inputs are different. So you have RS485, RS485, RS232 CAN bus, digital analog IOs, along with other options also. Yeah, so this is what we have. So we don't actually keep on building more and more hardware. Rather, so we only focus on building gateways as a company, and we implement, our primary focus is on creating the libraries or the firmware. So anyone out there who is interested to build firmware or write drivers, we are open to talk. So we can anytime talk, and like we would love to interact.
Okay.
Thank you, sir.
Thank you. If no further question, we came to the end of the session. I thank Amir for your valuable presence. Actually, I have seen your determination and growth from last 4 to 5 years when you started from here, and you struggle like anything to maybe get fast customer till getting funding, and today sustained with a crore of company. As told by not you to me, by our FTVI.NITrourkela, which is creating startup here. So we feel happy for you, so that our alumnus are doing good jobs outside, and also at the same time, I personally feel inspired to do such type of thing, so that apart from academical institute or academic research, we should grow up like you to build like a mini industry in our department. I mean, various portion, like somebody is working in firmware design and PCB design. So that should be a good combination of CA, CC, and at the same time different department. And then only we will have we produce a thing or a system which will actually be used by the social society or community. Okay, thank you, Amir. You can your camera is off, I think. So
no, the camera is on.
So it is not visible. You can switch on, switch off once. So
Okay.
I think Sir Pratik is there. Pratik, you want to ask anything, or before we are ending the session? So he was Pratik was asking many questions in online sessions about security. So Amir, thank you very much.
Yes.
Yeah, Pratik, you want
Hello.
to ask any? You want to ask any question?
Yeah. Yes, yes,
please. Please.
Sir, yes, sir, regarding two random number generation secret key in symmetric cryptography will be using how the IoT ESP32 will be used executions. I am asking to that Intel Pentium i3 processors, 2G of RAM, utilizing this type of Windows XP, SP3 operating systems. How will the ESP32 Arduino model will be used in that symmetric key procedures, encryption, decryption, time comparison process.
So I think this is, so you have to try it out. So I have never tried the encryption method that you are speaking here. So I think you have to try on your own. There is no hard answer, like right answer in hardware unless you try it. So if you are an enthusiast, so then you have to try it out, and hardware is really hard. So the question is like, it's not like a software, you just like have a bug and found it and fix it. So you have to deploy it in the hardware, deploy it in the environment. So I think I would suggest not to try with the Arduino environment, because Arduino environment has a lot of limitations, library limitations. So go and try ESP IDF core platform. So you can use platform IO, or you can use like Expressive IDF as a platform to build it, so that you can access the core libraries of the hardware and build on top of it. Arduino is built using those core libraries. So rather than using Arduino as a platform, so you use Express IDF, which are the core libraries of Expressive. Then you can
Sir, any
check.
Proposed algorithm for AES techniques for that? Yeah, any analysis package like NIST SP822? Yeah, other regarding any NIST statistical model will be analysis package for that particular symmetric key encryption decryption algorithm for that particular this technique.
So I am not aware of this, Pratik. Sorry to answer. Maybe it's too technical for me. So I am not the one who has the answer. So maybe I have to reach back to my technical team who knows it. But I don't have any answer. Sorry to do that.
Okay, Pratik, if you are asking like how whether you have done a AES based implementation and you want to, I think, implement in hardware. So as he is suggesting, you can use ESP32 or any standard 32-bit microcontroller or COTS commercially off-the-shelf processor available, like ESP32 or ARM-based processor. You can take it and you can do the encryption by two ways. Either you write C coding for that, or you can use their APIs or inbuilt libraries they are providing. And also at the same time, you can also use operating system ported on the COTS or processor, and there also you can do AES thing. So this is just what I understood from your question, so I tried to add. And apart from this, I think in online sessions also you were telling about Verilog implementation of AES and all. So I think you can use FPGA as also one of the platform to implement this encryption algorithm and to verify it. Okay, Pratik?
I think, sir, so I'm not very sure, but AES-256 is available as a like module inside ESP32. That's a very like I think a core hardware. It is part of hardware like block like in the ESP32 C series processors. Not sure, but yeah, you can check that.
Yes, sir. Any particular TRNG designs XOR gate multiple for metastability, jitter metastability for hybrid oscillations, XOR based post processors 64-bit. Particular AIS31 technique will be used for that, which you explained today. Model IoT model in TRNG.
Yes, yeah. In the backend, actually, yeah, it's the same algorithm that will be used.
Yeah,
because AES-256 is the global standard today, like in the IoT security, like say security process. So everyone is using AES-256 till the point we don't have a stable like security standard. So
Regarding
yes,
testing outcomes,
all the industry.
Yes, testing outcomes of different parameters, frequency, block frequency, as well as approximate linear complexity of this model will be calculated in IoT platform?
Yeah, all these platform, all these things, what you are asking, you can better get in FPGAs than CORDs. CORDs like ESP32, Raspberry Pi. These are actually processors available or board available for creating rapid prototyping. But there you can only just see the computational time, how fast they are giving you real-time results. But there, if you sit to finalize their operating frequency and other parameters, then you may not get that because those hardwares are freezed. You don't have flexibility to operate it. You have to only use it as an IoT. You can say end user. So that can be better done in FPGAs, or on other way it can be better done using IC designs, ASICs, which will give you far more better result than FPGA. But that involves again in investing time and money for IC fabrication. So I hope FPGAs will be good answer for that. Okay, Pratik?
So Pratik, you can try out. Pratik, you can try out with these two, like say OS, like porting into the hardware. One is Jeffrey, one is OpenWRT. So these are like say modified Linux OS. Very popular, very strong community. Like say, you can try out the algorithms, see the results. Like before you go into VLSI deep implementation. So maybe you can get the. I posted both of the links in the chat box. Like you can like check that. Like so I've said the link to the project details and the OS details. So thank you, sir. Thank you so much for inviting me. It was really a great experience talking to you. So maybe it would have been great, like if people more asked, like say maybe it would have been more interactive. So I think like people need to open up to talk. So that should not be a bad feeling, like say, talking about you, whatever you're doing. So it should be more interactive. As an industry person, I always expect like people to talk. Maybe so next time people should improvise. With that, like yeah, thanks everybody. Thanks for giving attention to my presentation as well as asking these questions. Thanks so much.
Thank you for coming and thank you for your time. Thank you.
Thank you, sir. It's a pleasure.